trying to look for pesticides. There are not any here. There are lots of flower trees here. Where's the pesticide?
Hi Mimi, what are you looking for?
Hi Hanan, I'm looking for these pesticides. Where can I find them?
Oh, I know. Here. Hi, we are looking for pesticide.
Oh, this pesticide is very good.
Oh, yeah, we found it.
Oh, nice!
The product is made from natural ingredients which is marketed as an organic nutrient solution. The main ingredients are first eucalyptus extract, orange peel extract, coconut extract, amino acid, and polysaccharide. The product also has two inorganic ingredients which are baking soda and ionized calcium.
Alright, now let us continue with one key organic chemical ingredient present in the product. In the selected product, we have chosen amino acid. Amino acid are organic compounds that contain two important functional groups, which is an amine group and also carboxyl group. This unique structure makes them fundamental building blocks of protein. Okay. In general, the formula for amino acid is H2N CHR COOH, where the R group represent the different side change that distinguish one amino acid with another from another amino acid. Therefore, the class of compound for amino acid is an organic compound, specifically belonging to the amino acid family. So, in organic chemistry, compounds are classified based on their functional group. For example, alkene are compound with a carbon-carbon double bond, while alkyl halide contain halogen atom attached to the carbon change. So, amino acid which we selected are organic compound that contain both an amine group and also the carboxyl group. So, this dual functionality place them in the amino acid family, making them unique unique building blocks of protein.
Next, we will see the exact name and chemical structure of amino acid. Amino acids are organic compounds that contain both an amino group and a carboxyl group. There are 20 standard amino acids found in protein. I will give you 4 examples of amino acid. First is glycine. The exact name is 2-amino-ethanoic acid. Next one is alanine, 2-amino-propanoic acid. Third one is leucine, 2-amino-4-methyl-butanoic acid. And the last one is valine, 2-amino-3-methyl-butanoic acid. And next, there is a chemical structure of amino acid.
Alright, looking at part 1, our main goal here is to form an alpha amino nitride intermediate. First up, the aldehyde gets protonate to make it highly electrophilic and reactive. Then, ammonia comes in as a nucleophile and attacks the carbonic carbon. After a quick proton transfer, a water molecule is eliminated, which gives us this key protonate imine intermediate, also known as iminium ion. Finally, the cyanide ion step in, attack the iminium carbon, and complete part 1 by yielding our alpha amino nitride. Moving on part 2, we need to hydrolyze a nitrile group under acidic condition to transform it into our final amino acid, which is this specific example is valine. Now, from step 1 to step 5 is a repetitive cycle of protonation, water molecule tracking, and proton transfer. This step-by-step process converts a nitrile group into an amine and eventually leads towards the carboxylic acid. By step 6, ammonia leaves the molecule as a living group, and after a final deprotonation, in step 7, we successfully get our end product, which is valine. To wrap things up, we can easily summarize this entire mechanism into 3 big phases, which is First, amine or imine formation, where the aldehyde react with ammonia, kicking off the water molecule. Second, cyanide attack, where the cyanide ion attack the amine attack the imine to give us the alpha amino nitrile intermediate. And third, nitrile hydrolysis, where we use water and acid to fully hydrolyze the nitrile group into the final amino acid.
Now, I will explain the reaction conditions and purification process involved in the striker synthesis of amino acids. After the alpha aminonitrile intermediate is formed, it undergoes acid hydrolysis under specific reaction condition to produce the final amino acid. The reactions begin with three main reagents, which are an aldehyde, ammonium chloride, and sodium cyanide. The initial reaction takes place at room temperature, where the aldehyde reacts with ammonia supplied by ammonium chloride to form the intermediate. Next, the alpha aminonitrile undergoes acid hydrolysis using dilute hydrochloric acid in an aqueous solution while heating under reflux. Reflux allows the reaction to be heated continuously without losing the solvent through evaporation, ensuring that the hydrolysis process completely. During this process, the nitrite group is converted into a carboxylic acid group to produce the final amino acid. After the amino acid has been synthesized, the product still contains inorganic salt and other reaction byproduct. Therefore, a purification process is required to obtain a pure amino acid. First, filtration is carried out to remove any insoluble impurities from the reaction mixture. Next, ion exchange chromatography is used to separate the amino acid from salt and other impurities based on their electrical charge. Finally, the purified amino acid is collected and dried, resulting in a high purity amino acid that is suitable for further application in the pharmaceutical, food and biotechnology industry.